In this lesson today, we're going to be talking about what happens when you change one of the attributes of a prism. So when we talk about the attributes, we're talking about the length and the width and the height. So let's go ahead and discuss what's going to happen when we change one of these measurements. So let's take a look at the first prism that we have here. Notice that we have a length of 5 inches, a width of 2 inches, and a height of 10 inches. Now, if I were to change the height of the first prism to half of what you see here, so half of 10 is going to give us 5, and that's going to lead us to the second one that you see. If that happens, what's going to happen to the volume is that the volume is also going to be cut in half. Anytime that you change one attribute on a prism, it's going to change it in respect to what you changed. So in our case, we cut it in half, so the volume is going to be cut in half as well. Now, if we were to calculate the surface area of what would happen when we cut one of the dimensions in half, just like we did here with our height, what would happen to the surface area? Well, it wouldn't necessarily cut in half, but it would definitely decrease. So our surface area would decrease if we changed one of those attributes like this. Now let's go ahead and talk about, let's just talk about the width. Notice in the next one, we have a width of 2. So I still have my length of 5 and my height of 10, and I'm just going to focus on that width of 2 inches. What would happen if I were to change that width and I were to make it 4? And which means I would double my width and make it 4. What would happen to the volume is, well, exactly what I do to the attribute is exactly what's going to happen to the volume. It's going to double. And what's going to happen to the surface area? Well, it's definitely not going to double necessarily, but what it's going to do is it's going to increase in size. And the last attribute that we have here, let's go ahead and take the length. So this time we have a length of 5 inches, we have a width of 2 inches, and I'm sorry, this should be a 10 inches. Go ahead and change that. And I'm going to go ahead and change it over here as well. I'm sorry about that. So we have 10 inches. And what I did is I took that length there and I multiplied it by 3. So I tripled it. So what's going to happen to my overall volume of my second shape is, well, it's going to triple. And of course, by tripling something, you're making something bigger. So what that means is that my surface area is going to increase. So basically, anytime that you change an attribute, the volume is going to do exactly what you did with the change. So if you doubled it, it's going to double. If you tripled it, it's going to triple. If you cut it in half, the volume is going to cut in half. But if you change one of those attributes to make it bigger, the surface area is going to increase. And if you change one of the attributes to make it smaller, your surface area is going to decrease. Okay, now that we know a little bit about changing attributes, let's talk about the idea of a scale factor. So let's look at this example. Prism A has a volume of 100 cubic inches, and Prism B has a volume of 50 cubic inches. What is the scale factor between the two prisms? So you can see that Prism A has 100 inches cubed, and Prism B has 50 inches cubed. You can see that I basically cut that cube in half. So, I'm sorry, that rectangular prism in half. When you divide something in half with the volume, you actually have a scale factor of exactly that, a half. So in this case, my scale factor is a half. Now, what if we looked at this cylinder below? Cylinder A has a volume of 6 cubic inches, and cylinder B has a volume of 24 cubic inches. What's the scale factor between the two cylinders? So if the first is 6 inches cubed and the second is 24 inches cubed, basically what happened is I multiplied it by 4. So the second cylinder is 4 times as big as the first. So my scale factor is going to be simply 4. Notice that with the first example, when you're making something smaller or you're reducing its size, your scale factor turns out being a fraction. And then the second example, when you start with a smaller figure and move to a larger figure, your scale factor ends up being an integer number. Okay, let's answer this next question. What is the scale factor between a prism with a volume of 15 meters cubed and a second prism with a volume of 45 meters cubed? So you can see here that we're starting with one that is smaller than the other, and I'm moving to a one that is larger than the other. So when I'm moving from something small to large, I'm going to go ahead and I'm going to multiply it by a scale factor that is an integer number. So 15 times 3 is going to give us 45. So my scale factor is going to be 3 meters cubed. What is the scale factor between two prisms, 30 centimeters and 15 centimeters? So this time I'm going from a large figure to a smaller figure. You can see that 30 is being cut in half. So that is going to make my scale factor 1/2 of a centimeter. Okay, now that we kind of have the idea here, let's go ahead and do some more attributes. The width of the rectangular prism is changed from 5 centimeters to 20 centimeters. And the other dimensions stay the same. What is the volume of the prism with this change? So you can see here that I'm basically going to be looking at my width. My width here is 5. Okay, what I'm going to do is I'm going to change that number to 20 because that's what the problem states. I think it's inches, inches. All right, so if that happens, I want to know what is my new volume. So volume is length times width times height. So my volume is going to be my length, which is my, we're going to say 8. My width, which is 20. Let me go ahead and erase that. Let's try that again. My volume equals my length, which is going to be my 8. My width, which is going to be 20. And my height, which is going to be 3. Okay, and feel free to interchange those numbers. That's perfectly fine. So 8 times 20 times 3. That's going to give me a volume of 480. Okay, well, 480 inches cubed, that's going to be my answer. Now, I do want to show you something very interesting. Now, let's go ahead and just calculate the original volume that I had. My original volume was going to be 8 times 3 times 5. And 8 times 3 times 5 is going to give me a volume of 120 inches cubed. So my original was 120. But when I took that attribute, that width, and I multiplied it by a scale factor of 4 to give me 20, watch what happened to the volume. If I take my ending volume of 480 and I divide it by 4, it's going to give me 120. So basically, I could have just taken my original volume of 120 and multiplied it by 4, and that would have given me my answer as well. All right, let's look at another one. A rectangular prism has a height of 12 inches and a volume of 60 cubic inches. The height of the prism is changed to 6 inches, and the other dimensions stay the same. What is the volume of the prism with this change? I really don't need to do any calculating with this problem because I already know that whenever I have a dimension, which we have the height is 12 inches, and it says that we change the height of the prism to 6. Didn't we take the original and cut it in half? So if I cut it in half, I'm going to take my volume of 60 cubic inches and I'm going to cut it in half to give me 30 cubic inches. And that's all I really need to know for this problem. All right, I think I have one more problem here for you. A new prism is created by changing only one of the dimensions. The volume of the new prism is 1/3 the volume of the original prism. Circle the figures that could represent the dimensions of the new prism. So, my original prism is given here. Notice that my side lengths are 18, 12, and 6 feet. I want to know which of these is the new prism. You can choose multiple answers here, but the thing that you need to keep in mind is the volume of the new prism is 1/3 the volume of the original prism. So, two ways we could do this. We could calculate the volume of our original prism, and then we could calculate the volume of all 6 of these prisms to the right. That would take a lot of work. That would definitely work, but I'm going to suggest something. Here's what I'm going to suggest. We're going to look at our original prism, and then we're going to look at each individual prism to the right. So let's go ahead and do that. I'm going to go ahead and call this number 1. I'm going to look at my dimensions. Do I have 2 dimensions that are identical to my original prism? Which I do. 18 and 6 are identical. Now, I want to keep my focus on the one that I'm putting in a box right now. Take a look at him and take a look at the corresponding side length on the original. Is that new number 1/3 of that side length? And 4 is 1/3 of 12. So this is going to be one of the new prisms. Let's do that again. I'm going to look at my second prism here. I'm going to call it number 2. And I'm going to look and see if any of them match up. You can see that 12 and 6 match up to my original prism. And I have a 6. That's my box one. 6 is 1/3 my original of 18. So this is an answer choice as well. Okay. Let's go ahead and look at the third one. I'm going to go ahead and find any side lengths that are the same. And I have 18 and I have 6 are the same. And the one that's different, the attribute that's different, is this dimension. And he corresponds with our 12 feet. Notice that 36 is not 1/3 of 12. It's actually multiplying 12 by 3. So it's actually going the other direction. So this is not one of our answer choices. Alrighty, let's look at the next one. Let's go ahead and match them up. I have 12 and 6 from my original, and the only thing that changed was 54. 18 times 3 is going to give me 54, and that's not 1/3. My scale factor here would be 3, and I'm looking for a scale factor of 1/3, so this is not one of our answer choices. All right, the next one, I'm going to go ahead and find my matching dimensions. Here they are, and then I'm going to focus my attention on that third one. If I have a 2 here, 2 is 1/3 of our original. So this is going to be one of our answer choices as well. And the last one. Alrighty. I'm going to go ahead and match up our original. Here they are. And here is the side length that is different. And you can see that from the original, it was cut in half. Well, we're not looking for a half, we're looking for a third. So this is not one of our answer choices. So that is one way you can do this problem. Another way is you can calculate the volume of the original prism and then calculate the volume of all 6 prisms and figure out which one has a third of the original volume. But I personally like using that second one. Okay, that ends our lesson on the changing of the attributes of our prisms.